An ocean current represents ocean water in continuous movement, generated by wind and differences in water density. Ocean currents are driven by winds blowing predominantly from a single general direction, called prevailing winds. These winds include the trade winds, the westerlies, and the polar easterlies. The direction of these winds is determined by the force caused by the Earth's rotation, the Coriolis effect. In a hypothetical situation in which the Earth has a single ocean and a single continent, the trade winds in the tropics would blow the upper few hundred meters of the water from the east to the west. The current would split upon hitting the continent. A part of it would flow back along the equator, while the rest would change direction northeast and southeast to the westerlies. If these branches reached the continent again, they would split once more. Some of the currents would travel back towards the equator, while others would change direction and flow, deflected towards the west, due to the effect of the polar easterlies. For this reason, two interconnected gyres flowing in the opposite direction would form in both the northern and the southern hemispheres. The irregular shape and position of the continents, however, modify ocean current patterns. For example, in the southern hemisphere, the second gyre can travel around the Earth in the zone of the westerlies without coming in contact with a single continent. Currents that move from the equator toward the geographical poles and carry warmer water than the surrounding waters are called warm ocean currents. Currents that travel from the geographical poles toward the equator and carry water that is colder than the surrounding waters are called cold ocean currents. Water currents do not only move horizontally, but vertically as well. The animation shows the surface and deep ocean currents of an idealized ocean. Vertical motion is caused by differences in temperature and salinity. Warm water near the equator has a higher salinity and density due to evaporation. Moving northward, the water cools down while its salinity level remains constant. Since its density is higher than that of the lower water mass, the surface water sinks into the ocean basin and flows back towards the equator, forming a cold, deep ocean current. Here, the cold body of water rises, thereby closing the cycle. In reality, the surface and deep ocean currents in the oceans form a global system called the global conveyor belt. Deep waters flow the most intensely in the North Atlantic deep water. The North Atlantic deep water can be found in the eastern part of the North Atlantic Ocean, near the end of the Gulf Stream, where it sinks and continues to flow southward as cold water current. It travels almost around the entire planet, rising only at the Indian Ocean and the Pacific Ocean to continue as warm water current. The time it takes for a water molecule to travel around the planet is up to 1,000 years. Ocean currents have a significant impact on the Earth's climate. When warm water currents reach a coast, that area will have a higher annual mean temperature. The mean temperature near cold water currents is lower than the average temperature of that particular latitude. For example, the annual mean temperature of Western Europe would be 5 to 10 degrees Celsius lower without the Gulf Stream.